Yeah, we're off to a great start here because I am boldly planning to do live demos during my little intro here. And given that I started right off with PowerPoint failing, that's a little bit of an inauspicious start, but hopefully this will work better than normally demos do. So I just wanted to give you some metrics. I think that one of the great things about working with the TerraSwarm team is what an extraordinary team it is. I love you guys. Most of you are here in the room, and it's been great fun and also incredibly productive by any objective measure. Now, this afternoon we're going to have demos and posters, and we have a secret committee that is going to select the best poster and the best demo, and we're going to give cash awards, which come out of my pocket. Don't worry, it's not DARPA money. So just hopefully we've named these awards after our two colleagues who we lost in the first year and a half of the program, Ben Tasker and David Wessel. And so I hope that, well, I wish all the students and postdocs good luck with getting this, and hopefully you've got a great demo or poster, and so we'll see what comes of it. So I wanted to start by just taking some slides from 2014, so that was 3 years ago when we were really had built up the first head of steam in the project. And in my intro talk at the annual meeting then, I kind of gave a challenge problem, which was this adaptive robotic swarm system, where the idea was that, you take a robot, you unbox it in some location, it wakes up in an unknown place, you have to bootstrap a process somehow, so you give it credentials for Wi-Fi, it broadcasts some discovery packet, it gets some replies, and then it searches for accessors that match those replies. So these are pieces of downloadable code that it can use to get access to these devices. So it finds a camera, for example, that it's going to recruit to look at its environment, and it then instantiates the accessor for that camera, takes a picture, and finds that there's no light in the room. It's a dark picture, so then it finds a light bulb. It does a search for a light bulb interface, gets an accessor for a light bulb, instantiates that accessor, turns on the light, and then requests a picture to be taken again, and then it's able to take a picture with light. So that was 2014, and that was kind of the challenge problem. And I think we've actually met this challenge problem, and I'd like to try to, hopefully this will work better than PowerPoint, but I'd like to give you a live demo of this. So, whoops. So, come on, stop blinking. So, environment that we use to stitch together accessors. So accessors are little snippets of code that can be put together. They have well-defined interfaces applications. And so, for example, this is an accessor that accesses a camera, and the camera that it's accessing, in this case, is this camera right here that I saw on my USB device. So it actually discovers whatever cameras are available in the local environment. And just to show you what this is doing currently is searching for things that it recognizes in the environment. So the applet here is actually searching for these AR tags, which are just hanging from the table right up here. So one of these AR tags, this one, is identifying a device, which is one of Prabal Dutta's bleeds, as he calls them. So this is a multi-sensor battery-powered device that communicates by Bluetooth to a little BeagleBone Black there, and it then publishes its sensor data either via MQTT, which you can keep in the local environment, so that's for local communication, or via the GDP, in which case it can be accessed from anywhere and it gets logged. One of the sensors on this is a light sensor, and so what I'm going to do is put it right on top of this light bulb, okay?
and so I was blocking the tag there. So you can see hopefully you can read this. The light flux is a fairly low number here. This is I'm not entirely sure what the units are for these numbers. We'd have to ask for Bob, but I can tell you this is a relatively low number, so it's not detecting a lot of light. But fortunately, there is also a tag for the light bulb, and I can turn it on in some color by submitting this to it, and then I can go back to the bleed, and you'll see that the light flux is considerably higher, 865 versus 17 on the previous instance. Okay, now there's one of the key things. I'm going to show you how this works, right? But one of the key things is that these devices are discovered in the local environment, and the code is to access these devices is downloaded from a swarm box that is sitting right here. And in fact, the devices themselves and the services themselves advertise themselves to the swarm box. So when you bring one of these devices into an environment, it notifies the swarm box and provides the swarm box with an accessor to it. And in this case, it identifies itself by one of the AR tags, and then that enables my little application to detect it. So one of the other devices that has advertised itself to the local environment is this little robot down here, okay? And there's this robot right here on the floor, and Matt here has programmed the robot with a little accessor that allows me to do either tell it to go forward or to spin. So if I tell it to spin, it'll spin. It gives me a bunch of sensor data while it's spinning, okay? Now, we have a couple more services here. So here's a kind of an ad hoc one that is sitting right there in Christopher's laptop. So the idea is that, you know, Christopher brings his laptop into here, gets an IP address to DHCP. Nobody knows what that address is. I don't know what that address is, right? He starts up the service, and he publishes an accessor to that service to the swarm box, and then because he's associated that with a tag, I can identify that service and instantiate the sounds on that laptop by you know, just invoking. Tell jokes during their talk, I'll stand by with this happening and do the jokes for you. Okay, I'll give you the laughter. All right. So, were there any others?
Light bulb.
Oh, there's another light bulb over here. So this one is actually a light bulb from a different manufacturer.
Has a completely different interface, a different network connectivity. So the accessor for it is a significantly different piece of code, right? This is a Philips, that's a LifeX. And if I want to turn on that Philips light bulb, I just turn it on like that, okay? Now, I'm going to turn it back off, and maybe I should go back and turn off the LifeX also, because that red light is going to be really annoying if I leave it on. Okay, so let me then stop this running and show you kind of how this works. I'll do this by switching back to a little PowerPoint animation, but this is showing the same image. So as I mentioned, the camera accessor discovers whatever cameras are available on the local device and gives me, you know, a menu option of choices for those cameras. Then I have an accessor for a service that recognizes objects in the field of view. Then I have a little script that's an application-specific script that handles situations where there might be more than one tag, more than one thing recognized in the environment. This is what does the arbitration to pick among those things that are in the environment. Then the most interesting piece here is a little script and accessor combination that takes a tag that's been selected and then queries the swarm box for an accessor associated with that tag, and then it provides that accessor as output to a mutable accessor, which then instantiates that accessor for accessing the device. Now, at that point, the device starts spewing out sensor data, if it produces sensor data, and it starts listening for actuator commands. The sensor data is going to a little script that constructs a UI. It's just using HTML5. So the reason that the UI was in a browser is because on this particular platform, it's a browser that you would use to handle an HTML5 UI. On this platform, you can natively invoke HTML5 UI, right? So it depends on the platform that you're on how you invoke this UI, but in any case, it's basically just HTML5 that is used to produce this UI. And these scripts construct that user interface, which is admittedly a pretty primitive user interface. I'm not a, you know, we're not UI designers here. If we had more time, we would have gotten Bjorn's team to help us really create cool, usable interfaces here. But anyway, we get then this kind of interface in a very ad hoc way. Now, we can also, the sound service that was running on Christopher's laptop illustrated how you construct these services. So I'd like to show you that I can turn the whole story around here. And on my own laptop here, run a service. So this is a service that was developed by Matt, who's sitting right up here. And what it does, I'll just go ahead and run it. And when I run this, it will construct an accessor for this service using my IP address, which is not a priori known, right, because that was obtained from DHCP. So it constructs that accessor, publishes that accessor to the Swarm box, and now Matt is going to run the same app that I was just running and point his camera at the screen here and type a message to all of you. So what do you want Matt to say? Okay, so the issue here is that, you know, in a completely ad hoc way, we created this little app and made it part of the room, right? This is the idea of the Swarm box, right? The Swarm box becomes kind of the nexus of locality, and services in the room advertise themselves to the Swarm box and make themselves available to clients in the room, okay, whoever has access to the Swarm box. And you can, in a very ad hoc way, create these. Now, in this Cape Code environment, I can take this sort of app development and then code generate it to something that will run standalone, for example, on a device like this BeagleBone Black, in which case that service then becomes part of the room infrastructure and not just, not just a demo to be run during an annual meeting, okay? So that's kind of the overall story here, and I want to point out that although, you know, there's lots of stuff about this demo that's really pretty primitive, it really pulled together a whole bunch of stuff that is going on among the various PIs in TerraSwarm. So I'd like to emphasize how how the various projects within TerraSwarm fit with this. First of all, what I've just shown is kind of astonishingly heterogeneous, right? So I access the BLE sensor via MQTT, which is this pub-sub service, which can be used, in this case, that's what I would use if I wanted to keep purely local connectivity. So for example, I want to keep the data private in a local environment, and I don't want it to be accessible outside. On the other hand, if I want to log the data and I want to have it available more broadly, then I can access these same sensors through the GDP. Similarly, we can access the power blade sensors. There's actually a power blade under that light bulb, but we decided that we didn't really need to show you that. But it would tell us whether the light bulb was on just by measuring the current that's going into the light bulb, okay? And again, we can access those via MQTT or GDP. The Hue light bulb was accessed via an HTTP interface that, because of the way Hue works, it has Philips has its own little gateway here, okay, and that just provides a RESTful interface, and that's just a legacy piece of capability, and we just wrap that access to that in this accessor definition. The robot is running ROS, and we create an accessor that simply uses ROSBridge, which is a service that can publish commands to the ROS infrastructure, which then the robot will have implemented some service within ROS to respond to those commands. The audio service was via a WebSocket. So when Christopher started up that audio service, it published an accessor to the Swarm box that had built into it this WebSocket server, the IP address for this WebSocket server that he's running on his laptop. And then finally the message board, this message board service that I instantiated here was using HTTP, and then the accessor would access that through HTTP. But all that was kind of invisible. You just provide input to these accessors, you get the sensor data back. Now, the various aspects of TerraSwarm that are involved, this is a pretty astonishing list, right? The idea of principled composition, the idea of smart gateways, which is the Swarm boxes, the idea of location-independent communication and logging, the GDP. Security is hard to demo, right? But we have developed this security infrastructure where the Swarm box can serve as a local, what do you call it, authentication server, okay? So that you can do authentication and authorization on a purely local basis without having to go to the cloud. So even if you lose network connectivity, you don't end up losing connectivity locally because of your inability to authenticate, all right? So that was one of the security contributions. It uses devices that we've developed, particularly the devices that Prabal developed, the Urban Heartbeat Toolkit, and the signpost is also, we have an interface to the signpost that is constructed the same way, which you can see on the demo floor later today. Localization and spatial ontologies. This we decided to simplify the demo some, but Anthony is working on this truly astonishing technology where we won't need those tags, okay? So you have a codification of what's in the room in other forms, such as the location within the room, and then you can use tagless odometry using indoor localization, and then using the inertial sensors on your device to identify what you're looking at. And then you wouldn't need those tags then in order to access some device that's in your local environment, okay? Data summarization is an obvious thing that you would want to do because here, when I went to this device, I got a snapshot of data, what's it showing now. But usually for a lot of sensors, that's not what's of interest. What's of interest is, what happened in the last week with this sensor. And so the data summarization can be used to give you a service that would summarize what happened in the last week, okay? So this is the work from UW. Privacy, opacity, and obfuscation are obvious opportunities. Discovery is an intrinsic part of this. Resilience, I'll come back to this. Let me go through a few of these, okay? So principled composition. So this has been a major part of the theme 2 of this project, and this demo that I showed, this composition mechanism that Accessors is using is all about rigorously defined interfaces that have contracts that can be formally specified, and then these contracts can be composed so that you can take a service designed by one person and instantiate it in an application designed by someone who never has encountered this service before, okay? So the idea, that really is only possible with well-defined interfaces. So if you bring a new device into the room and it publishes its accessor to the Swarm box, if that accessor has a conforming interface definition, which is a checkable property, then these applications can access that device using that accessor. So this is a big part of the Theme 2 effort in TerraSwarm. The technology, the kind of software infrastructure we first demonstrated in the DARPA Wait What demo, which I think many of you saw. Swarm boxes, exploiting locality. So here, we're using this, in the demo that I showed, we're using the Swarm boxes for three things actually. They provide a context by hosting a database that identifies objects in the local environment. And those objects have told the Swarm box about themselves. So this is sort of a very decentralized configuration mechanism where a device walks into the room, it finds a Swarm box using discovery, and then provides that Swarm box with an accessor that can then be instantiated to get access to that device. The Swarm boxes also host this service that we call Auth, which is a locally centralized, globally distributed authentication and authorization service. And then the Swarm boxes also host an MQTT broker for purely local pub-sub communication. So on the security side, the locally centralized, globally distributed authentication is based on this idea that came from our Michigan team, from Alex Halderman in his which he first instantiated in this Let's Encrypt project, which makes a free and open certificate authority. And what we've done is we've adapted that so that each swarm box can have its own certificate authority running, and you can set up a completely local security environment. It's capable of coordinating over the network, but it's also capable of functioning completely locally. The Urban Heartbeat Toolkit, I want to mention, I just showed you the BLE sensor, but there's quite a few others. So the plug load meter is a really clever device. You just put it right through the plugs of these guys. And there's various others that Prabal's group has developed. The signpost, if you go to the demo floor, you'll see this similar kind of user interface and accessor-based reading of historical data pulled from the GDP. So if you're you're taking advantage of the GDP's logging capability, you can get historical data and do analysis on that data and present analysis information through this kind of a user interface. The ability to use localization and spatial ontologies in principle should enable us to completely get rid of these tags, and I encourage you to go and see Anthony's, well, I think Anthony's going to be talking about this later on, but he also has demos on the exhibit floor that shows this idea of being able to just completely eliminate these tags and be able to just look around the environment, recognize services, sensors, actuators that are in your environment, and then start interacting with them. I already said several times this ability to handle logging of information and this ability to leverage data summarization, right? Once you've been logging data, of course, logging data by itself is often not going to be useful because sensors are going to produce such a vast amount of data that, what do you do with that? You don't want to have a human, go through all that data. So what we really want is for this user interface to give you not just raw historical data, but a summary of what are the interesting things that have happened with this sensor in the last 48 hours, in the last 2 weeks, whatever time interval you want to look at. And this is the UW work, which is really quite spectacular in my opinion. There's huge privacy issues with all of this because, when you're accessing these services, you're also giving up a lot of information. And here we can leverage the work, again, from Michigan, that it gives us ways of basically fooling the eavesdroppers in such a way that our information that we want to keep private remains ambiguous, right? That's the whole idea of this opacity, is that you want to preserve ambiguity, plausible deniability, right? Discovery mechanisms. So there's various things that we've done with discovery. One of the nicest things, I think, and it's really a beautiful little tool developed by Prabal's group called Summon, which, if you can install it on your iPhone. I have it on my iPhone, and it'll tell me about all of the devices that are in this room on the network, communicating via Bluetooth or Wi-Fi, and we use that extensively in developing these technologies. There's also tremendous opportunities for exploiting Roosba's work and Roosba's group from Texas A&M. One of the most beautiful things, I think, of the work about the work that they've done is that they've shown us how you can take multiple sensor feeds and use them to gain context information about what's going on. So, for example, if you have a video feed and you have a feed from an accelerometer on a watch, then you can tell who's wearing the watch because you correlate the data from the accelerometer with the motion sensing in the video, okay? That gives you context information that you can then use to build applications in an ad hoc way in a local environment using similar kinds of applications that we've looked at. I think it's a beautiful idea, and hopefully Roosba will be talking about that some more later and showing you some demos. I also want to say, I saw this demo for the first time this morning, but Chadlia, is Chadlia here? Chadlia is right over here. This light bulb that I just showed, right? So I instantiated an accessor for it, and I had control over the light bulb. Well, she showed me a demo this morning where if you take that light bulb, I've turned it on, and I unplug it, so it fails, then her service will discover another light bulb in the room and turn it on. Okay, so it's a way of constructing a resilient system, leveraging the discovery by monitoring the health of these devices and then in an ad hoc way switching to backup devices when you have those available. So I think she's going to be showing that on the exhibit floor. So if you like pulling light bulbs out of sockets to see what happens, I suggest you stop by and talk to Chadlia later. With Jan's work, Jan's been leading this work that was kind of a significant add-on to TerraSwarm, sort of late in the project, this human intranet, and this, of course, makes the imagination run wild, right? Now we can start to think about humans being able to interact with their environment in much richer ways that don't involve, you know, the screen and mouse kind of interaction that I showed. So all of these topics connect in with this humble little demo. I mean, this is, you know, not that fancy a demo, but it really pulls together quite a few of the things that are going on in TerraSwarm. I think John and Rusba are going to be talking about the enhanced conference room. This demo was put together in the context of that challenge problem, okay? And so I will let them tell you more about that challenge problem in general. But I also want to mention that there are a few of the major TerraSwarm contributions that we couldn't figure out how to integrate with the demo, although with a little imagination, it's not that hard. So the beautiful work on controller synthesis based on formal methods by Richard and George and Sanjit, and the mobile platforms work by Vijay and George and Raul. I think those are, you know, it doesn't take too much imagination to figure out how to integrate those with the demo, but that would have made it probably even less likely to actually work just because, you know, there's a certain level of complexity beyond which demos aren't going to work anymore. The ability to do verification on these is something that's hard to demo, but I think you sort of have to take my word for it that the key idea behind these accessors is very much the contract-based design of Alberto and Sanjit, and the mechanisms that they can use to analyze designs and analyze the correctness of composition directly apply to this demo. David's smallest sensors, his millimeter cube sensors, also, you know, sort of trigger a lot of potential imagination things that you could do. So, for example, imagine somebody swallowing one of his sensors in a pill and then using face recognition to be able to look at the, you know, pH of someone's stomach acids overlaid on a display of their body or something like that. You know, it's not hard to imagine that kind of thing happening. So humanizing the swarm, I think, you know, Bjorn would be the guy who would know how to make all of this actually something that we would want to use rather than, you know, something that is just a toy. And he's doing some beautiful work in that direction. And of course, there's also the work on machine learning for the masses that Jeff has done that we couldn't figure out how to integrate. So I apologize to anyone that I might have left out, but there's a lot of great stuff going on in the project. I want to remind you, this is the domain of the problem area as we identified it in our first kickoff meeting in 2013. And it's a pretty incredibly broad list of topics, and the idea that we could actually pull something together that has elements from all of these, it kind of blows my mind personally. But so with that, I think we're still a little bit ahead of schedule, so should we take time for questions and discussion? Okay, questions and discussion. Somebody want to break the demo? Figure out how to? If you, anyone who has downloaded Cape Code can actually access these devices. Yeah, so Bjorn has a question back there. Oh, why don't you go first?
I guess I'm closer to the microphone, so I just wanted to ask, so these are great ideas, and one of the big things that I would love to see is so if someone were interested in taking this to apply it to a specific problem, say someone at DARPA, how would they go about it? Is there a mechanism for them to go do all this? I mean, it seems like you have to pull together the very strength of it, which is all this contribution of R&D, is also a difficulty if you're trying to pull this together into an honest-to-goodness, application. So how would you recommend that we try and do that?
Well, that's a really good question. So maybe a good way to do that is to actually show you a little bit of detail in the demo, because these are actually these components are actually not that complex. And part of the key idea here is, and I think the best articulation of this idea actually comes from Beth, who's sitting right back here, who is one of the key developers of this accessor technology. But I'll try to use Beth's words. But you know how a browser gives you kind of gives a human a universal interface to services that are out there on the network, right? And the way that the browser works, at least for non-trivial services, is it downloads code that is a proxy for that service, and then it runs that code within a sandbox. Okay, that's what happens when you go to your bank, for example. You download JavaScript, you run that within the browser. In this case, what's happening is that the Swarmlet host, which is what runs this application, this thing is a program, okay, and that host is functioning like a browser, but not for humans to access it, but for devices to access it. Okay, so the idea is like a browser in the sense that, when it instantiates an accessor for one of these devices, it has downloaded potentially untrusted code, just as a browser would download untrusted code from some website, and then it runs that within a sandbox, right, where it controls the resources that device has access to because it's provided that sandboxed environment within which that script runs, right? So you can think of this as kind of the browser for things instead of the browser for people. It's a browser to enable composition of things. So I think it's a very powerful idea. It obviously requires a lot of polish to get it, out there, but I think the idea is very powerful.
Thank you. George.
Yeah, so I want to get your thoughts on the use of tags. So you mentioned on the one hand, it's kind of obtrusive to have these checkerboard patterns all over the room. It'd be nice if research can give us solutions that get rid of visual tags. On the other hand, they also have this really nice feature that they tell me exactly what I can control in the room. And so just this morning I taught a class about Bluetooth Low Energy, and we were talking about beacons, right? And someone said, so I've heard about these beacons for years. Where are they? I never see them out in the world. Yet there are deployments, it's just they're not in your face, but you're being tracked, by running an application on your phone and passing by the beacon. So there seems to be this trade-off of, on the one hand, making your access points into these smart enhanced rooms visible, but then they're obtrusive. On the other hand, they can be invisible, but then you no longer know what they might be doing on your behalf or on someone else's behalf with your data.
Yeah, that's an incredible insight. That's why we have Bjorn on the team, right? Because we need people to think about those things. And it just occurred to me that, I had never really thought about it this way, but, when you go around and you see a QR tag on something, that's a message to me that I can access a website, right, which I wouldn't have thought to do otherwise, except that there's that QR tag sitting right there, right? So it has that function that hadn't occurred to me. I was thinking we would universally want to get rid of them, but you have a valid point that if you get rid of them and you make things too invisible, then people don't even know the service is there.
You didn't mention Swarm OS in your talk too much. But I assume there's a Swarm OS layer underlying everything you're showing. And so my question is, how do you see that evolving going forward?
So I think that, so Swarm OS we've never thought of as a monolithic thing. And I think that we've made, that there are two key parts of this, of the TerraSwarm project that I would call both essential elements of the Swarm OS. One is the GDP, which is a kind of a global fabric with that logging and location-independent communication. And the second one is this accessors framework, which is this kind of browser for things, right? And these are both meant to run on top of other OSs, so they're not replacements for OSs. They are fairly platform independent. So we've demonstrated, for example, that these swarmlets can run. Obviously, they run on a laptop. They also run on phones. You've been using an infrastructure that is agnostic to iPhone or Android called Cashmere. What's it called? Cordova. Thank you. We also can code generate it and run it on the Swarm box, okay? And we've even demonstrated being able to run it on very deeply embedded devices using a very lightweight JavaScript engine called duct tape, so with a very small memory footprint. So we can actually deploy these things to fairly small devices. So we're trying to get at this idea, you know, a browser is something that runs everywhere, right, and gives access to these things. And so we're trying to get to that. Now, obviously, there's a lot of polish that has to happen for that to really get, you know, industrial scale and design. And my hope is that we don't face the valley of death after TerraSwarm, that, you know, we can't invest in that further, but we're working on that.
So actually, Cape Code's available for download. So I don't know if you could download this demo today and run it, but there's a chance you could download it tomorrow, and there's an even lower chance that it could work. So it's available. And Edward,
actually, if you do download it today, make sure to double-click on the camera and choose a camera that you have, because I accidentally checked in a version of the demo that hardwires in this particular camera. And so unless you have this particular camera on your machine, it's not going to work. But it discovers whatever cameras you've got, and the default camera, if I switch it and run it using the default camera, then it just uses the one.
But we'll have that fixed by tomorrow. So, yeah. So that's sort of our path for deployment.
A lot of good work by the overall TerraSwarm program, and congratulations to everybody for that. But you mentioned, Edward, just recently or just now about not being the death of this and taking it forward. Where is, or what is your vision to take it forward, and where would you take it from here?
Well, that's a good question. I mean, we've formed a research consortium that we call iSci-Fi that is picking up the accessors work in particular. The GDP is being cultivated within the Swarm Lab, which again is an industry-sponsored partnership. And so we hope that, you know, industry remains interested enough to keep these things going. So, yeah, that's what I have to say. I also, frankly, believe that there's potentially enormous opportunities for startups here, and I encourage students and postdocs who are interested in doing that. I personally feel like I'm too old for that, but I'm happy to provide counsel.
Thank you very much, Edward. Great demo. Here you showed discoverability through the Swarm box. Did you guys also explore discoverability, interoperability of things between themselves and not necessarily going through a smart gateway? That seems more like a web approach.
Yeah, in fact, I was trying to hint at that with this, you know, this ability to start up a service here that then, you know, that device was able to access that service. But keep in mind that because these things are designed to be deployed on even quite lightweight devices, that can create this thing-to-thing interaction, right? So yes, our prototype is using laptops for the things, but these things can be deployed even to, bare metal devices running no OS, just duct tape. What's the smallest device you've run these swarmlets on?
Let's see, it's about 1 meg of RAM, so it's not very much. You could probably run it in 300K, but it's hard to have a network stack that small. You really have to work it, but that's the size we're looking at.
So it starts to get to the point where you can embed the accessor hosts into, Leaf devices. It's starting. We have at least concept demonstrations that seems plausible. Okay. So